Good evening, Rancho Verde High School pre-calculus class. This is Mr. Langston coming at you. It is September 25th, 2017. It is a Monday, and this lesson, yes, I know, I taught it to you on Thursday. So, yes, I'm finally getting to the video. I'm sorry for it. It's been busy. So, without much further ado, let's get into the content and get things taken care of for you. So, you have a warm-up. And all you have to do on the warm-up is plug it in, plug it in. So what I'm talking about is, let's put it in blue. I want to do blue. So you have x is 2. So 2 to the second power, 4. 2 to the third, 8. 2 to the fourth, 16. 3 to the second, 9. 3 to the third, 27. 3 to the fourth, 81. 4 to the second, 16. 4 to the third, 64. And 4 to the fourth, 256. 5 to the second, 25. 5 to the third, 125. And 5 to the fourth is 600 and, I don't even know why I put 24. I was thinking of fourth power. 625. That's it. That's your warm-up. It's that crazy easy. So we're going to be doing section 3.1, exponential functions and their graphs. You have a basic description of an exponential function. It is f of x is equal to a to the x, where a is a number greater than 0, a is not equal to 1, and x is any real number. So to get into the nitty-gritty on an exponential functions, you need to evaluate the function at the indicated value of x. Again, it's like the warm-up. Plug it in, plug it in. So you have f of 0, because x is 0, equals 2 to the 0. Well, what's 2 to the 0 power? Anything to a 0 power is 1. You should remember that from Algebra 2. F of 2 equals 4 to the negative 2 power. Now, remember a negative power? What it means is if it's in the top, and when I say in the top, this is what you're going to do. Make it into a fraction. And if the negative power is in the top, move it down to the bottom. And if it's in the bottom, move the power up to the top. So for instance, this is going to become 1 over 4 to the positive 2 power. 1 over 16. So what you're going to do. F of x is equal to 3 to the x at x equals 1. So f of 1 equals 3 to the 1. Well, 3 to the first power, 3. Yeah, it's that easy. Oh my God. So you've got the graphs of exponential function here. Sketch the graph of each function in the same coordinate plane. F of x equals 2 to the x, g of x equals 4 to the x. So let's start with 2 to the x. What I recommend you do is make a t-chart. So I've got my x's. I got my f of x's or my y's. I'm going to start at 0. 2 to the 0, that's 1. So at 0, I'm at 1. If I go 1, 2 to the 1, well, that's 2. So at 1, I'm at 2. At 2, 2 to the second power, 4. So already, and at 3, 2 to the third, 8. Now I'm just off the chart. I'm somewhere over here. Let's go in a negative 1 direction. 2 to the negative 1, That's 1/2. So at -1, I'm at 1/2. -2. 2 to the -2 is 1/4. And if I have -3, that's 1/8. Really tiny here. So what I have for my graph, it's going to shoot up. And of course, like I messed that part up. And what can I say? Nobody's perfect. It's going to shoot up right there. Now, I can also, I have x, g of x. And it's the same concept. So at 0, I have 4 to the 0 power, which is 1. At 1, 4 to the first power is 4. 2, 4 to the second, 16. 3, 4 to the third, 64. At -1, I have 4 to the -1 power, so that's already at 1/4. -2, 4 to the -2 power, 1/16. So for this one, 4 to the 0 is 1. They both have the same point here. At 1, I'm already at 4. At 2, I'm at 16. I'm like way up here. I don't even know. I can't even kind of estimate it. Let's go smaller. At -1, I'm at 1/4. And at -2, I'm at 1/16. So what's going to happen is it's going to reach its asymptote quicker, or not reach it, but kind of get closer to it quicker. And it's also steeper. So we have a one-to-one property where you can solve for x. To do this, what you're going to end up doing, just making your life easier, is get it into the same base. So for instance, 9. I'm going to make it into a base of 3. So that's 3 squared equals 3 to the x plus 1. Now that I have the same base, I've got base 3 and base 3, I can essentially ignore the bases and just look at the powers, because the powers have to be the same because my bases are the same. So what I have is 2 is equal to x plus 1. And now you just solve for x, minus 1 on both sides. X equals 1. There you go. I've got 1/2 to the x power. That's equal to 8. I can do a couple things with this. I can change this 8 into a 1/2 power, or I can actually change this 1/2 into a power of 2. And the way I do that, remember how I talked about you can take negative powers, you take the reciprocal? Well, I can do that too. So I can take this 1/2, make it into 2/1, and the way I do it is I make my power now negative, because a negative says take the reciprocal. So if I reverse this and I take out the negative power, I end up taking the reciprocal, which is 1/2. So I didn't change anything. This becomes 2/1 equals -x, or I can just say 2 to the -x, and that equals 8 is 2 to the third. When I get the same bases, I can cancel these 2's out. I can say -x is equal to 3, or x equals -3. It's called the one-to-one property. And now the basic rule is get both sides to be the powers of the same base. And then from there, you can cancel out your bases. You can also do transformations. Big transformations that I want you to know is if it's paired, if the shift, and when I say shift, I mean the c, is paired with the x's. If it's minus c, it's a shift to the right. If it's a plus c, it's a shift to the left. And again, when it's paired with the x's. If it's pardon me, if it's not paired with the x's. If it's a minus c, it's a shift down. And if it's a plus c, it's a shift up. And then you have a reflection over the x-axis. And that's when you just take the negative of whatever the exponent is. Or sorry, the negative of the entire, I don't know what to call it, function. Or you reflect over the y-axis. And that's when you take the exponent and you negate it. So let's actually see some examples, shall we? Complete the following transformations of the graph f of x equals 2 to the x. So what I have here, I have f of x equals 2 to the x plus 1. So I've got a plus 1 with the x. And remember, when it's a positive with the x, it's to the left. So I'm going to go left 1. And then I have minus 1, and it's not paired with the x. So when I have a negative, it's a down. In this case, down 1. So I'm going to take a normal f of x equals 2 to the x function. So it's this. And this equation is a transformation of that, where I go left 1, down 1. So I go left 1, down 1. 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 So my new exponential function looks like that. And I got y equals 2 to the negative x. Remember that when it's to the negative x power, it's a reflection on the y-axis. So what I'm talking about, normally, my graph looks like this. But now I'm going to reflect it over the y-axis. So I'll put it in blue. Sorry about that little part right there. Didn't exactly end up looking pretty. There you go. It's a reflection across the y-axis being right here. So what I did is I just took this and I flipped it around the y-axis. And there you go. So we have this compound interest, A equals P to the 1 plus R over N to the NT. And this is for interest that is compounded, not continuously compounded, just compounded over a specific interval. So what I have right here is an example. So y equals P 1 plus R over N to the NT. And now you invested a principal of 12 grand. What's my rate? Well, it's 3%, but I got to make that into a decimal. So 0.03. And that's all over N, the number of times it's compounded. Semi-annually means twice a year. So in this case, 2. And it is to the 2, t is how many years? 5 years. So I've got y equals 12,000 times it by 0.03 divided by 2 is 0.015. So 1.015, I added it to 1. to the 10th. This is where you get a calculator and plug it in. Okay. So when I get my calculator, and I'm just going to do this on the side, you're probably not even going to see this work. So when I get the calculator, I have 1.015 to the 10th. So typing in calculator because I didn't have that ready. 1.015, and now I'm going to take it to the 10th power. That's 1.16, and now I'm going to times it, or multiply it, by the principal, which is 12,000. That's going to give me 13,926.49 cents. 13,926.49. 13,926.49. That's how much I get after 5 years, including my principal as well. So there you are. Another thing that you need to know is area equals PE to the RT. Now, this is for continuously compounding. So it's not something where it compounds a certain number of times a year. I'm talking it goes on like every second, every minute, every hour of every day, it's accruing interest. And I remember this easier because it spells out PERT, which is kind of a shampoo that I never really use, but I just remember their commercials because I don't have a life. So that's how I remember that. I don't have an example of it for you right now. Again, it's like a plug-in problem, just like this. It's a plug-in problem. So I hope this helps you guys out for your homework. I'm sorry I got this to you late. I hope you have a good day. Thank you for watching. Take care. Peace. Do your homework. And afterwards, have a good day. Bye.